Hi guys, so here we're going to talk about the first part of significant figures, which numbers are significant, and really why this all matters. So you'll need your notes, which is your pen and paper. We're going to talk about why numbers are significant and which numbers are significant. Now let's talk about the word significant. What does that mean? It means that it actually matters. It depends, or it's used in the calculation. So measurements are approximations. We saw this when we were measuring volume, right? So we took the measurement in a graduated cylinder or burette, and we estimated one more extra digit. That last number is our uncertainty. Measurements are approximations. So we have the example 3.47 milliliters. So the last number, that 7, is the approximation. The 3.4 should be pretty much exact. So the second type of numbers are going to be counting numbers. They're exact numbers. So we know that a foot is equal to 12 inches, that there can be 24 people in a class, or 12 eggs in a dozen. We would never say that we have 24.00000 students in a class. It's just 24. So significant digits are digits that you actually know, or numbers that you actually know in a value. So there's a few simple little rules. First rule, pretty easy. Anything that's not 0 is significant. So any 1 through 9 number that is in that number is going to be significant. So here we have 1.367. Each of these are going to be a non-zero number. So let's count up how many we have. We should have 1, 2, 3, and 4. So here we can say that there's 4 significant figures, or you can say 4 sig figs because it's easier saying it that way. Let's go down to the second example. 1, 2. There's 2 sig figs here. So anytime you have a 1 through 9 number, that's going to be significant, always. When it gets a little hairy is when we actually have zeros. So we have a few rules for zeros. First of all, if there's a 0 in front of the entire 1 through 9 number or digits, they are not significant. They're leading zeros. All right, so we have 0.983. Well, 9, 8, and 3 are all significant because they're a 1 through 9 digit. But that 0 in front is not going to be significant. We still have to keep it there. Don't eliminate it, because then you would ruin the decimal place and everything. But we would say that we have 1, 2, 3 sig figs in this number. Let's take a look at the second example. Well, we know that the 2 is significant because it's a 1 through 9 digit, so that's good. Those zeros are all in front of that 2, so they're not going to be significant. Again, don't eliminate them, don't cross them out or anything, but we will say that there's only 1 sig fig there. Alright, so that's for any leading zeros in front of a 1 through 9 digit. Next, we have sandwiched or middle zeros. So any zero, between a 1 through 9 digit are significant. So we have 9,053 liters here. That 0 is between a 1 through 9 number, so it still is significant. So we have 1, 2, 3, 4 sig figs here. Let's take a look at the second example. We have 0.0304. Now, the 3 and the 4 are definitely significant because they're a 1 through 9 digit, but these zeros in front of it are not going to be because they're leading zeros. That was back in rule number 2. Let's take a look at this middle 0. It is a middle 0, so it will always be significant. So we have 1, 2, 3 significant digits, and I've underlined all 3 of them for you there. So any leading zeros in front of all the 1 through 9 digits are not significant. The middle zeros are significant. Here's when it gets a little weird. Zeros at the end of a number. So zeros at the end of the 1 through 9 digit are significant if there is a decimal point somewhere in the number. Anywhere in the number. So let's take a look at this first example. We have 320 liters. So the 3 and the 2 definitely significant. This 0, this is a lagging 0 or 0 at the end. And it's only going to be significant if there's a decimal point somewhere. And we can see that there is a decimal point right there. So we have 1, 2, 3 sig figs. Alright, so let's take a look at the second example. 0.230. Alright, that's a leading 0. That does not count. The 2 and the 3 do count. Now this 0 does count because there is a decimal point anywhere in the number. It doesn't have to be next to it. It just has to be anywhere in the number. So we have 1, 2, and 3 sig figs for this one. And your third example, we have 97.00. I've already underlined the 9 and the 7 because they're definitely significant. Those 2 zeros are at the end but it is significant because there is a 0. So here we have 4 sig figs. For Rule 5, it's pretty much kind of telling you the same thing in Rule 4. So zeros at the end of a 1 through 9 digit are not significant if there's no decimal point anywhere in that number. So if there's no decimal point, they're not significant. So we have 320 here. Okay, same thing as before. However, there is no decimal point anywhere in here. So only the 3 and the 2 are significant. So we only have 2 sig figs. The second example, 9,700 ATM. ATM stands for atmosphere, which is pressure. We'll deal with that in Unit 3. The 9 and the 7 are definitely significant, but let's take a look at the zeros. There's no decimal place or decimal point anywhere in the number, so those are not significant. Again, we're not going to eliminate them. I haven't crossed them out or anything like that. I've just shown that they are not significant in there. So there's 2 sig figs in each of these. All right. Scientific notation, only the base numbers are going to count in here. So we don't care about the exponent at all. We just care about these numbers down here. So let's take a look at this. 1.34 times 10 to the negative third. Again, we're just looking at the base number. So we have the 1, the 3, and the 4. Those are all significant, so there's 3 sig figs there. Let's take a look at the second example, 3.05. So we have a middle 0 right there that is significant always. So there's, again, 3 sig figs right there. Don't worry about the exponents. All right, so make sure that you use your rules for significant figures for any measurements. Have a good day, guys.